زين. So one of the, let me give you an example. عندنا خلينا نقول مثال we have a blue star, okay? So we know that the blue star in the spectrum, it has, if we're talking about frequency or wavelength, it has, what do you think? Higher frequency, right. So what does it mean, a relationship with the wavelength? Okay, so step by step. We have a blue star, عندنا نجم زرقاء, okay? When we talk about the color spectrum over here, and we're talking about the blue, do you think the frequency is higher or lower? Higher, okay. So when we talk about the relationship between frequency and the wavelength is shorter, right? Because we have higher frequency, so shorter wavelength. Okay, so shorter wavelength. And this is a spectrum, by the way, that scientists use. It's called the black body spectrum. And when we're talking about a blue star, for example, and we have a very low wavelength, or very low wavelength, what scientists do, they check the peak wavelength. And from the peak, they have an equation that would give us the temperature. For now, I have an exercise for you. I need you to be in groups. So I think each table has two sets of exercises. So maybe if you can divide into two groups. Okay, let me explain the exercise for you, or activity. So everyone has this, right? عادي لو تكونون في جروبات. These you can divide into groups of two, if possible. يعني انتوا البنات مع بعض. هاي ورقتكم, okay? Okay, so you would see here we have the activity. You will notice that we have a spectrum. So we have a couple of spectrums, I think 4 spectrums, and each spectrum is for a specific star. Okay, and then what I want you to do is I want you to check on the spectrum and see where is the highest peak, okay, so that you know what is the highest wavelength. And from the peak, you get the wavelength. You will notice there is an equation here. Using the peak wavelength, you can get the temperature. And from here, I want you to classify or list which is the hottest star to the lowest. And I'm going to go around to see if you need any help. I'll give you 5 minutes. Time's up. Time's up. Okay, I'm going to share the answer, but I'd like each of the groups to tell me their answers first. You should. There is a trick for this. You can finish it in less than 1 minute without even calculating. No, it's right. The way that you did it is right. Exactly. Hey, exactly. This is the trick. Using the wavelength without calculating, you would know which star is the hottest and which is the coldest. Yeah. Yes, that's correct. And for you, that's correct. أشوف مالكم again. A, D, B, C, correct. And what about you guys? Also the same? Okay, great. Most of you got it right. The trick is here not just to check using the equation. Equation is there to make sure you get the right answer. المعادلة موجودة عشان تعرفون بالضبط هل أنتم صحيحين ولا لا. بس من السبكترم, from the spectrum you can know exactly from the wavelength إذا كانت النجمة حارة ولا باردة, if it's cold or hot, from the wavelength itself. Okay, so let's let me go to the next section. Okay. Okay, we did that. So now, since we talk about how do we characterize the stars, what are the elements made up of the stars, and how do we differentiate between each, let's start the actual stellar journey. So we'll start بنقول أول شيء شو قصة النجمة, شو يعني كيف هي بدايتها, كيف انتهت, يعني من البداية. Yes. The what? Yes, the luminosity actually, it's different. Using our next exercise, we're going to be using that. Yeah. Her question was about the luminosity or the brightness of the star. We're going to use it in the next exercise. So you can see here, to make it simple, we compare the lifespan of the stars to human lifespan. But there is something very important that we need to note down, and what do you think it is? So stages of development is similar, but there is something that plays a bigger role here, which is time. So when we compare time, when we talk about our human lifespan, you can say that maximum we reach is around 80, 90, but we're talking about stars, we're talking about millions, yet billions of years. So this is a very important factor when we talk about the lifespan. الحين يوم نرمس عن النجوم, زين نحن نقدر نقارنها ب المراحل التطور اللي عندنا مثلنا يعني كناس يعني, بس في شيء مهم نحن لازم نحطه ببالنا اللي هو الوقت. نحن نرمس عن مثلا نقدر نوصل 60 سنة 70 سنة, بس يوم نرمس عن النجوم ياسين نرمس عن بلايين السنين. Okay? So let's start from the beginning. For example, the fetus stage. What happens is, some of you already also explained that in our solar system we have, or when we talk about our galaxy, there is gases. We talk about there's asteroids, there's planets and all that, but there's also gases, there's also dust, planetary dust. So what happens is these clouds of dust and gas, we call them nebula. And from the nebula, what happens is when these gases and dust start to compile, they at one point collapse within itself. When that happens, we call it a protostar. فنحن نعرف إن في حين مثل شبيهة للغيوم يكون فيها غبار وغازات. زين هالغيوم الغازات والغبار يعني at one point شو يستوي من كثر ما إنه وايد كثيف يطيح على نفسه أو يعني يكون مثل في أكشن, فشو يستوي نحن نسمي هالشيء بروتوستار لأن الماس ماله وايد عالي وايد كثيف. زين from the protostar what happens is from this action it starts slowly rotating. There is an action, and from this action it becomes spinning fast. And do you know when there is an action there is also energy, there is heat. So from this action what happens is as the temperature reaches 15 degrees Celsius, we already talked about the elements in the gases, right? The dominant element is hydrogen. So when we reach 15 degrees Celsius, what happens is the hydrogen atoms start to fuse. It starts a nuclear fusion to helium. And when this happens, a new star is born. So this is how stars get born. النجوم شو يستوي؟ الحين نحن رمسنا عن الغازات اللي موجودة. فمن الأكشن اللي يستوي ما أنا قلت لكم بروتوستار يبتدي إن يدور يلف على نفسه. فهاي الأكشن يعطينا حرارة. ومن هالحرارة شو يستوي؟ الهيدروجين يكون مثلا درجة الحرارة توصل 15 مليون ديجري سلسيوس، فالهيدروجين يتغير إلى هيليوم. أول ما هاي يستوي النجمة يعني انولدت. Okay. So this is where the star is. It starts going through infancy to adulthood. I have a question. How old is our star, the sun? Who can tell me how old is the sun? من يقدر يقول لي كم عمر الشمس؟ ها؟ 1.5 what? No. لا أكثر. More than 10 million. Guessing. Less. 2.5? 4.5 billion years. تخيلوا انتو 4.5 billion years, the sun. And it's in this stage, it's from the fusion, it's in the mean sequence actually. You would know from the color even. So, yes. We'll talk about that after a while, after I tell you the stages. Her question كان سؤالها كيف تعرفين كم عمر الشمس مالنا؟ فعقب بنرمس على الموضوع. الحين we talked about adulthood, but what happens is, how do you know that the star reaches, for example, if we're talking about human lifespan, middle age? What do you think happens? Color change, there is something happening, right? Why did the color change? ليش تغير لون النجمة بهالستيج؟ The temperature will change because something happened before. So if I give you, yeah. Exactly, okay. Yeah, you're getting it. Okay, so شو يستوي؟ الحين as we know, the petrol one day is gonna end, right? So hydrogen at one point is gonna end as well. مثل ما نقول نحن البترول بيخلص، hydrogen بعدين بيخلص at one point. So what happens is, hydrogen is finished. There is no more hydrogen fuel. What's left is the other elements over there, which is helium, the other dominant element. So what happens is, why did the color change and why did the size change? There is no process anymore. There is no fusion of hydrogen into helium. So it starts stopping, and what happens is that there is helium. We have a lot of helium. So before that happens, because there is no process, so gravity wins, الجاذبية تفوز، فيبتدي النجمة starts compacting to itself. When that happens, the temperature increases, okay? And we have helium, we still have helium there. As soon as that happens, the temperature rises, so helium starts fusing into other elements. Okay, so now what's happening is that helium, it's using helium to change into other elements. فلأن حين ما في هيدروجين، زي درجة الحرارة استوت عالية، فيستخدم الهيليوم اللي موجود عشان يسوي elements ثانيات. For this stage we call it a red giant stage. Okay, and it takes around 2 billion years. ياخذ بليونين سنة يعني عشان هالstage it ends. So when we're talking about the gravity and the pressure, okay, so hydrogen is not there anymore. The star starts compacting to itself, okay? So gravity is winning.